All right, welcome to the Drawing Lewis Structures video. This is going along with the Drawing Lewis Structures practice, and if you haven't watched the lecture on this, you should really go back and get that done. I'm going to walk through all the practice problems so you can check to see how you're doing, or if there was one you're stumped on, I'll help you work through it. So we're going to start with CF4. We're going to do our electron count. Carbon's in group 4. It's got 4. Fluorine is in group 7, but there are 4 fluorines, so that gives us 28. 4 plus 28 is 32 valence electrons. Okay, next I'm going to draw my skeleton, central atom in the middle. Carbon is listed first, so it goes in the middle. I'm going to connect it to the 4 fluorines. Okay, that uses up 2, 4, 6, 8 electrons. So that gives me 24 left to place. So now I'm going to go to the most electronegative thing. Well, as it turns out, they're all fluorine. They're equally electronegative. So I'm just going to go to one of the fluorines. It does not matter which one. And I'm going to start placing my electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, and now I look to see if everybody's happy. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. They're all happy. One final count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Boom. Great. I am done. Going on to next one, NH3. N is in group 5, so it has 5. H is in group 1, so it is 1, but there's 3 of them. 5 plus 3 is 8 valence electrons. I'm going to put my N in the middle because it's my central atom. I'm going to put 3 H's coming off of it. I'm not going to worry about, you could put one going down, you could put one, it doesn't matter what 3 sides you put it on, okay? So 2, 4, 6, I use 6 valence electrons, so I only have 2 left. I'm going to start with the most electronegative thing. Remember, electronegativity increases as you go up and to the right. And so nitrogen is going to be more electronegative than hydrogen, since hydrogen's in the upper left. And so I've only got 2 to place. I'll put them next to nitrogen. Let me see. Nitrogen is 2, 4, 6, 8. That makes it happy. Each hydrogen has 2. This one has 2. This one has 2. Remember, hydrogen is the only one that's happy with 2. So that one's happy. Let's do one final count. 2, 4, 6, 8. Boom. We're done. There's NH3. Okay? Hopefully, so far, so good with that. Okay, bear with me. I'm going to adjust things just a second. All right, here we go. Going down to the next 2. Here we go. We've got oxygen, O2. So I'm going to do my valence electrons. It's in group 6, but there's 2 of them, so 12 valence electrons. I'm central atom first, but there's not really... Get it all nice for you. There's not really a central atom since it's O2, so you're just going to do an O to an O. We use 2 valence electrons there, so there's 10 left, right? So since they're both the same, they're not, one isn't more electronegative than the other. So 2, 4, 6, 8, 10. It doesn't matter which O I start with. Let's count to see if this is happy. 2, 4, 6, 8. It is. This one happy. 2, 4, 6. It's not. So I'm going to take this 2. I'm going to erase it. Now, I took the bottom 2, but does it have to be the bottom 2? No, you could take any 2 electrons from your oxygen that had the more electrons. So any pair, pop them in the middle. And now we've got 2, 4, 6, 8, 2, 4, 6, 8. And now let's do an overall count. 2, 4, 6, 8, 10, 12. Good. All right, SF2. Sulfur has 6 valence electrons. Fluorine has 7 times 2, which is 14. 14 plus 6 is 20 valence electrons. So I'm going to put my sulfur in the middle. I'm going to put fluorines coming from either side. It doesn't matter, top, bottom, left, right, wherever you put them. Does not matter, okay? I used 2, 4 electrons for that. So I've got 16 left. I'm going to start placing my 16 by my most electronegative. And so if I look on the periodic table, fluorine is more in the upper right, so that's going to be fluorine. 2, 4, 6. And it doesn't matter which one you start with. 8, 10, 12. 14, 16. Oh, that's nice. So let's look. This fluorine's got 8. This fluorine's got 8. This sulfur's got 8. Overall count, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Boom, that's where I want to be. Awesome. All right, let's go on to our next couple. These ones are ions, so I'll show you how to do that. It's not really difficult, but it might throw you for a loop the first time you see it. So we'll do our counts like always. Oxygen is 6. Hydrogen is 1. And the -1, remember that's a charge because it's got an extra electron. Okay, So what I would do for my count then is I've got 6 plus 1, so that's going to equal 7 electrons, but I've got a minus 1 here, so I'm going to add an extra 1, which gives me 8 valence electrons, okay? And now I'm going to go as always. So I'm going to do an O with an H coming off of it, doesn't matter which way the H goes. Okay, I used 2 electrons for that, I've got 6 left. I'm going to put them around the more electronegative thing, which is oxygen. So we're going to go 2, 4, 6. Again, it doesn't matter which side of oxygen you start on. And so now let's see, oxygen is happy with 8, hydrogen is happy with its 2, 2, 4, 6, 8. Good, I'm done. All right, CO3, let's do our counts. Carbon is 4, oxygen is 6 times 3. Whoops. Remember, those are coming from the group numbers, group 4, group 6. Okay, 18 plus 4 is going to be 22. And then look, this negative 2 means I have an extra 2. Okay, so that's 22. I'm going to add a 2 to, so that is actually 24 valence electrons. Okay. And so now I'm going to start with my central in the middle. I'm going to put oxygens coming off 3 sides, doesn't matter which 3. I use 2, 4, 6 in that. So that gives me 18 left. I'm going to start putting around the more electronegative thing, which in this case is oxygen. Doesn't matter which oxygen, doesn't matter which side. I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. I've placed them all. Let's take a look. Oxygen 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Carbon 2, 4, 6. It's not happy. So means we're going to need a double bond. It does not matter which oxygen you pick. Pick one oxygen, erase a pair of electrons, doesn't matter which pair you take, and make a double bond. And there you have it, CO3. All right, moving along to our next examples. Okay, pH3. Let's get our counts going. Phosphorus is 5, group 5. Hydrogen's in group 1, but there's 3 of them. 5 plus 3 is 8, so we have 8 valence electrons. Phosphorus is going to be in the middle. We're going to have 3 hydrogens coming out from it. Doesn't matter which side. I can do something like this. Doesn't matter. How many did I use? 2, 4, 6. So I've got 2 left. I'm going to start by the most electronegative thing, which is phosphorus. I'm going to put them right here. And now phosphorus, 2, 4, 6, 8 is happy. Each hydrogen has 2, which makes hydrogen happy. And just double quick final count. 2, 4, 6, 8. Good. All right, let's do C2H6. Carbon is in group 4, so it's going to have 4, but 4 times 2 is 8. Hydrogen is in group 1, but there's 6 of them, so there's 6. 8 plus 6 is 14 valence electrons. Okay, it says VE over there. Let's draw our skeleton. This one you might think, what? So the central atom is listed first, so that means carbon is central, but there's 2 of them. So that means there's going to be 2 carbons. And then, maybe you see where this is going, there are 6 hydrogens, and if we're going to divide them equally, that means 3 for each. So 1, 2, 3, 1, 2, 3. Okay, so how many electrons did I use for that? 2, 4, 6, 8, 10, 12, 14. So I have none left. Let's check for happiness. Okay, each hydrogen wants 2, 2, 2, 2, 2, 2, 2. Hydrogens are happy. What about carbons? 2, 4, 6, 8. That one's happy. What about this one? 2, 4, 6, 8. Oh, it's happy. Great. Double check. 2, 4, 6, 8, 10, 12, 14. Yes, that one's done. Nice. All right, CBr4. Carbon is got 4 in group 4. Bromine is a halogen. It's in group 7, but there's 4 of them, so 28. 28 plus 4 is 32 valence electrons. Central atom is carbon. We're going to have 4 bromines. Okay, that used 2, 4, 6, 8. Which is going to be 24 left. And all the bromines are equal electronegative, so we're just going to start placing with whichever one you want. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Let's check. Carbon, 2, 4, 6, 8. Yes. Bromine, 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Oh, they're all happy. Double, triple check. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Yes, we did it. Okay, P2H2. Phosphorus has 5, but there's 2 of them, which gives 10. Hydrogen has 1, but there's 2 of them, so that gives 2. 10 plus 2 is 12. All right, so similar to our C2H6, now we've got P2H2. So we've got 2 phosphoruses, and we're going to divide the hydrogens evenly, which means 1 hydrogen off each. At this point, you guys, it does not matter where you put them. If you put them top, or if you put them left, you put them right. As for right now, it doesn't really matter where you put them, okay? I like to keep things symmetric.
So let's count our electrons. 2, 4, 6. Okay, so I've got 6 left to place. I'm going to put those around the more electronegative thing, which in this case happens to be phosphorus. So pick one, doesn't matter. 2, 4, 6. Okay, I ran out. Let's check for happiness. Hydrogen's got 2, it's happy. This hydrogen's got 2, it's happy. This phosphorus has 2, 4, 6, 8, it's happy. This phosphorus has 2, 4, 6. It's not happy. So we need to have a double bond. Now, I can't take anything from hydrogen because it's already sharing its 2 electrons. So the only thing that can possibly give up a pair to share is this phosphorus. It doesn't matter if you give the top or the bottom, doesn't matter where they come from. Erase a pair, put them in the middle, and now that is a double bond. All right, coming down the home stretch here, N2. Nitrogen has 5, but there's 2 of them, which gives 10 valence electrons. So let's draw our skeleton. We used 2, and so there's 8. We're going to start with the most electronegative, but they're both nitrogen, so they're equally electronegative. So we're just going to start placing. Doesn't matter which one. 2, 4, 6, 8. Okay, and again, it doesn't matter top, bottom, left, right. So this one, 2, 4, 6, 8. That one's happy. This one only has 2, 4. Okay. So we're going to start obviously making some bonds here. It doesn't matter which pair you erase. Let's say I erase this pair. Put it in the middle. This left one still has 2, 4, 6, 8. This right one now has 2, 4, 6. So I'm going to have to erase another pair. Again, it doesn't matter if it's left or right. It doesn't matter what side it comes from. I'm going to erase it. Put it at the top there. And so now we have 2, 4, 6, 8, 2, 4, 6, 8. Total count 2, 4, 6, 8, 10. Great. And now lastly, we've got NO minus 1. All right. So N is going to be 5. O is going to be 6. This gives us 11 valence electrons. And then up plus 1, because that negative 1 means there's an extra electron. So we actually have 12 valence electrons. Okay, let's draw it. There's not really a central atom here. It's just 2 connected. And now we are going to place with the most electronegative. Oxygen is more to the upper right than nitrogen is. So we're going to start with oxygen. We used 2 to connect them. So that's going to give us 10. So we're going to start with oxygen. 2, 4, 6. And it doesn't matter where. 8, 10. Okay. So let's see, 2, 4, 6, 8, it's happy. 2, 4, 6, that one's not happy. So we're going to take a pair from oxygen, doesn't matter which pair at all, and they're going to share it in the middle there with a double bond. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12. And there you have it. That is how you draw Lewis structures, and hopefully that helps you with the practice worksheet.